Welcome to the Explainer. Today we are going to do something a little different. We're taking a real AQA GCSE Chemistry exam question, and we're not just going to answer it. Oh no, we're going to get right inside the mind of the examiner and figure out exactly how every single one of those marks is awarded. Let's get into it.
You know, sometimes it can feel like exam questions are written in a secret code, right? Well, today, consider us your code breakers. We're going to go way beyond just finding the right answer. We're going to understand the why behind the mark scheme.
All right, our target for today is question 03. This is from the June 2021 higher tier chemistry paper. And I picked this one specifically because it's a fantastic mix of different skills. It's the perfect training ground for sharpening your exam technique. So, what are we up against? Well, it's a hefty 10-marker all about extracting metals, and it's split into 3 parts. We're going to have to do some calculations, use the periodic table, and even think a bit like an industrial chemist. It's a brilliant test of your all-around chemistry knowledge.
Okay, let's dive right into the first part of the question. Our mission, should we choose to accept it, is to basically play detective. We need to uncover the identity of a mystery element that they've just called R.
Here it is, the first problem, exactly as it appears on the paper. So they tell us the total mass of all the starting chemicals, the reactants, is 150. The trick here is to work backwards. We need to figure out the mass of the bits we do know, hydrogen and oxygen, to figure out the mass of our mystery element, R.
Now, before we start plugging numbers in, let's get our game plan sorted. First, we'll work out the mass of all that hydrogen. Then we'll take that away from the total of 150 to find out how much the RO3 part weighs. And finally, we just subtract the mass of the oxygen, and whatever is left has to be the mass of R. See? It's a really logical step-by-step puzzle.
And here's how the math looks when you lay it all out. Those 3 H2 molecules have a total mass of 6. Take that away from 150, and you're left with 144 for the RO3. We know the 3 oxygen atoms have a mass of 48. So, 144 minus 48, and that gives us our answer. The relative atomic mass of R is 96.
Now, for the moment of truth, let's pull back the curtain and look at the official mark scheme. It actually shows a slightly different calculation method, but notice we end up in the exact same place, 96. And check out this key piece of extra information. Ignore units. This is gold. It means the examiner just wants the number. They don't care if you write anything after it.
So, we have our magic number, 96. The next part of the question is pretty straightforward. Take that number, grab a periodic table, and find out what our mystery element actually is. This is the number we're hunting for, the element with a relative atomic mass of 96. Let's scan across the periodic table and see who our culprit is.
And there we have it, molybdenum, or Mo. But wait, look at that extra info. This is absolutely crucial. Allow ECF. What does that mean? It stands for error carried forward. It's basically a safety net. It means if you messed up the first calculation and got, say, 95, but you then correctly identified the element for your wrong answer, you'd still get the mark for this part. That's a huge tip. Always attempt the next part, even if you think you've made a mistake.
All right, part 1 is done and dusted. Now let's switch gears for the second part of the question. We've found our element, but now we have a totally new task. We need to calculate the efficiency of a different reaction.
So, here's the setup. We're extracting tin from tin oxide using carbon, and the question wants us to work out the percentage atom economy. Now that sounds complicated, but it's really just a fancy way of asking, of all the ingredients we put in at the start, what percentage of their mass actually ends up as the tin that we want?
Before we do the math, let's just be crystal clear on what atom economy is. Think of it as a rating for how wasteful a reaction is. A high atom economy is good. It means most of your starting atoms end up in the final product you want. A low one is bad. It means you're creating a lot of waste. It's the mass of the stuff you want divided by the total mass of everything you started with times 100. And the process for calculating it is nice and simple. First, we add up the masses of all our reactants. That's the tin oxide and the carbon. Then we find the mass of the one thing we actually want, which is just the tin. Finally, we pop those two numbers into the formula and solve it.
Let's crunch the numbers then. The total mass of our reactants is 119 for the tin, plus 2 16s for the oxygen, plus 12 for the carbon, which gives us a total of 163. The mass of the desired product, the tin, is just 119. So we do 119 divided by 163, multiply by 100, and that gives us our answer, 73%.
And let's check in with the mark scheme. Yep, 73%. But again, don't ignore that extra information.
It's telling you not to panic if your calculator spits out a massive decimal. As long as you round it correctly to at least two significant figures, you are getting the marks. So 73.0 or even 73.01 would be perfectly fine.
And now for the final part. This is the big one. It's not a calculation, it's a longer written answer worth a full 4 marks. This is where we have to evaluate. We have to weigh up the good and the bad of a few different industrial methods. So the exam paper gives us this table. It's comparing 3 different ways to extract the metal tungsten. For each method, we can see the reactant they use, how much it costs, and what products you end up with. Our job is to use just this information to make a critical evaluation. And that word evaluate is the absolute key here. This doesn't mean just list what you see in the table, it means you have to be a judge. You have to look at all the factors, the cost, the products, how easy it might be to separate them, and then make a reasoned judgment, weighing up the pros and cons of each one. So how do you bag those top marks? Well, the mark scheme gives us massive clues. The examiners is looking for you to talk about a few key things. The cost of the reactants, for sure, but also the challenge of separating the products. And finally, the kinds of byproducts you get. A top answer will link these ideas together logically.
And this really gets to the heart of the problem. You have this central trade-off. Method 2, the one with hydrogen, is great because the only byproduct is water vapor, a gas. It just floats away, leaving you with pure tungsten. Easy. The problem? Hydrogen is expensive. Methods 1 and 3 are the opposite. They use cheap reactants, but they leave you with a big, messy mixture of solids that are really difficult and expensive to separate. A top-tier answer will focus on that conflict: cost versus purity and ease of separation.
Phew! We've made it through all 10 marks of question 03. So we've cracked the question, but what are the big lessons here? What can we take away from this that will help us in any exam? Here are your key takeaways. 1. Always show you're working out. You can get marks for your method even if your final number is wrong. 2. Error carried forward is your best friend. Never ever leave a follow-up question blank. 3. Use all the data they give you. It's not there for decoration. 4. Structure your evaluation questions by comparing pros and cons. And finally, number 5, and maybe the most important, treat that extra information in the mark scheme like a secret cheat sheet, because that's the examiner telling you exactly what gets the marks.
So there you have it. We've taken this question completely apart to see how every single one of those 10 marks is won. And the best part is, this method of deconstruction works on any question you'll ever face. So the only question left is, which one are you going to tackle?